We're going to talk about balancing redox reactions, and we're going to use the half reaction method. It's many steps, but it's a bunch of small steps, and if you practice these, I'm absolutely persuaded you're going to eventually find that really complicated reactions end up being easy. Okay, so let's look at this. First of all, a few points that your textbook makes, and that is redox reactions often take place in aqueous media, and they have hydronium ions, which are H3O+, which oftentimes we can just consider as H+. And they have hydroxide ions, or I should say, they have hydroxide ions, right, as reactants or products. Now, even though these products up here are not oxidized or reduced, they do participate in other ways, and so we're going to use them. These are very difficult to balance by inspection. I would say impossible, right? You can be tearing your hair out. So one useful approach to balance these types of reactions is to use the half reaction method, okay? And so here's what the half reaction method looks like. First of all, we write the two individual half reactions. I'm going to go through all these steps with you, then I'm going to demonstrate them, then I'm going to go back through them one more time, and all in this video, so it's going to be a little bit of a long video. So first of all, we write the two individual half reactions, the oxidation and the reduction. We've seen that. Then, watch this, we balance all elements except oxygen and hydrogen, okay? All elements except oxygen and hydrogen. Then we balance all oxygen atoms by adding H2O to whichever side is necessary. Then we add acid ions, right? Hydrogen, they're really protons, right? Hydrogen atoms by adding H+ ions to whichever side is necessary. Then we balance all charge by adding electrons. If necessary, we multiply coefficients so that we can cancel stuff. Watch this. And then we add them together, okay? So let's do an example. Okay, I'm sorry, one more thing. If we're doing things in basic media, that if we're told to do it in base, okay? After we're done with all that, then we add enough hydroxides to get rid of all of the H pluses to make them waters. On the side of the equation containing H+ and OH minuses, we combine these to yield water molecules, okay, and we simplify by removing water molecules. All right, and then last thing we do is we check everything and make sure everything's balanced, okay? So let's do an example. I know that was really fast, but you can rewind the video. You can write those steps down. I do recommend it, actually. So, all right, here's an example. First thing we do is we divide things up into the half reactions. So one half reaction is Fe2 plus goes to Fe3 plus, okay? And we'll do the other half reaction as Cr2O7 2 minus goes to Cr3 plus, all right? So first thing we do is divide up into half reactions, which I did. The next thing we do is we balance all we balance all the oxygens by adding water. So let me go to black and say, looks like I'm going to be adding 7 H2Os here, right? Because you see you've got 7 oxygens, okay? Add 7 H2Os. There's no oxygens to be adding up here because there's no oxygens, okay? So now I add H pluses, and it looks like there's 14. So it's going to be 14 H plus. Can you see that? Look at that. See, that's 14 hydrogens. I had the 14 hydrogens over here. Okay. And let's see. Now, go back up here. I think the next step then is to add the electrons. Yes, it is. So there's +2 here and +3 here. I'm going to have to add 1 electron over here to make the charges equal, right? +3 minus 1 gives +2. Can you see that? And this is a little bit scary for me. 14 pluses and 2 minuses. 14 pluses and 2 minuses give me 12 pluses. That's right. 12 pluses. And over here, I've got 3 pluses. Ooh, I can't believe I did that. I didn't balance I got to go back, folks. I didn't balance my chromium atoms. Look at that. Crud. See, look, there's 2 chromium atoms right here. Didn't balance those. Okay. But I'm going to do that right now, okay? Step 2 was balance all the atoms besides that. Oops, I don't want to do that. I just want to put a 2 in front of it, right? Okay. That was step, look at that. That was step. Balance all the elements besides oxygen and hydrogen. I'm going to go back to that. Oh, then after that, I'm going to be adding oxygens. Man, that's a mess, isn't it? Okay, but I'm going to go back to black. There's 7 oxygens here. There's 14 hydrogens over here. Got to have 14 over here, right? And now I add my charges up. 14 pluses and 2 minuses give me a 12 plus. And I have a 6 plus over here. So I'm going to have to add 6 electrons over here to this side, right? Can you see it? And up here, it's 2 pluses. I'm going to have to add 1 electron over here. Can you see that? 2 pluses give me 3 pluses and 1 minus, right? 14 pluses and 8 minuses. That gives me 16 minus, or rather 16 plus altogether, right? 16 pluses altogether. And over here, I've got, wait, that's not 16 pluses, sorry. Different color. 14 pluses plus 2 minuses plus 6 minuses give me, what is that? That's 12, 6. Give me 6 minuses total. Folks, I'm sorry, I can't count, right? 14 plus minus 2 gives me 12 plus minus 6 more gives me 6 pluses, right? I got 6 pluses over here and 6 pluses over here. That's correct. Let me get rid of this orange here, okay? All right, 6 pluses over here, 6 pluses over here. So these are balanced. Now what I have to do is I've got to make sure that when I add these 2 reactions together, the electrons disappear, right? Because you don't, the electrons are just for an accounting issue. So I'm going to have to multiply this one by 6. Can you see that? Watch, I'm going to add the reactions together now, and you'll see that everything's good. This was done in acidic media, so I'm going to have some acid left over, okay? Now watch, I'm just going to start at the top. That's going to be 6 irons. 6 iron 2 plus, right? Okay, I got that one. Now I'm going to come down here, plus 14H plus, that's correct, plus Cr2O7 2 minus, got that. My 6 electrons cross off with that 6 electrons, right? And so I'm going to say produces my 6 iron 3 plus, got that. Working my way across here. Plus 2 Cr3 plus, got that. Plus 7 waters. Okay, and that's it. I'm done. Okay, I do want to check everything now and make sure all my charges are right. I'm going to go back to orange for this, okay? So it looks like there's 12 pluses here, 12 pluses, 14 pluses, 14 pluses, and 2 minuses, plus 2 minuses, right? Which is equal to, what's that, 26, 24 pluses? Okay, what about this side over here? 6 times 3 is 18 pluses. Plus 6 pluses gives me 24 pluses. 24 and 24. This is correct, folks, okay? So now I'm going to walk through this one more time, but I'm going to do it with the slides, right? So we can do it slowly. First thing we did was we balanced the half reaction, or rather we pulled out the half reactions, right? That's the first thing we did, step 1. Write the 2 half reactions. Step 2 is balance all the elements except oxygen and hydrogen. So I have to add the two right there, right? Which I forgot to do the first time through, okay? Then we balance all the oxygen atoms by adding water molecules, which I got here, right? Because I had 7 oxygens here. I'm going to have 7 oxygens now, right? Step 4 is balance all the hydrogens by adding hydrogens. I had 14 hydrogens over here, so I got to add them here, right? Now I have to balance both sides by adding electrons, okay? So my 2 plus and my 3 plus are not equal, right? So I better put an electron over here to make them equal. And then over here, this is where this is complicated. 2 minus, 14 plus, right? 6 minus, right? That gives me 6 plus altogether over here. And then I've got a 2 times 6, that's 6 plus over here, right? Those are equal to each other. So I had to add the 6 electrons over here to make this equal. I did that previously, right? You saw me do that longhand a few minutes ago. Okay, and then after I do that, I've got to make it so the electrons that are produced equal the electrons that are consumed. This is like Hess's law. It's exactly like Hess's law. Okay, so 6 electrons, 6 electrons. That means I have to multiply everything by 6 up here in order to get them to be 6, right? And then I add everything together. See what cancels? My 6 electrons cancel over here and here. Okay, and that's why I multiplied the ones by 6 previously, right? So they can cancel. And then finally, I just check everything, and sure enough, everything's correct. So this is what we had on that slide when I did it longhand, and I've shown you how to do that 2 ways. So first of all, we went through the steps. I described the steps. We did that kind of fast because they're complicated, right? They don't really mean anything until you practice them. And then we did it here, okay, and then I stepped you through it again one more time. All right, so hopefully that's helpful. Might be good to pull out a piece of paper and predict what I'm going to do. This, I think, is a very valuable video. It's a little bit long, lots of steps in it. By the way, we're going to revisit this at the end of the semester, and it's the last thing that we do at the end of the semester. All right, good luck.